I'm going to design a tall building in ETABS. Here all the details of the building have been given. So as we can see that we have to apply the different loads to the different live load to the different sets of the stories. That is, from story 1 to 8 we have to apply the live load of 3.5 kN per meter square. From story 9 to 12 we have to apply the live load of 4 kN per meter square. From story 13 to 16 we have to apply the live load of 4.5 kN per meter square. From story 17 to 20 we have to apply the 5 kN per meter square. Here we are having the different details of beams and columns and slab. Here we are also having the details of shear wall. We have to use auto cladding. Auto cladding load is given here. We have to apply the wind load. So we have to consider the parameters in Bangalore. So now let's open ETABS software. Go to File, New Model. Choose the option as shown. Then OK. Now set the number of grids in X and Y direction. Now set the spacing between grids. Now go to simple story data and set the story as 20. Typical story height will be 3 meter and bottom story height will be 3 meter. Now go to custom story data, edit story data. Now we will apply the similar property for that. Go to story 8, master story, yes. Now similar stories to 8. Change all the similar stories to 8. As we have changed all the similar stories, now go to the story 12. Story 12. Now set it as master story, then similar to story number 12. Now go to story 16. Set it as master story, similar to 16, similar to story 16, similar to story 16. We do not need to change the other stories because it has been already set. So we have defined all the similar stories properties. Then click OK. Then choose grid only option. Then OK. It will take some time. Now as we can see that grids of different stories have been drawn over here. So now it's time to define the material. So go to define material properties, add new material, region India, material type concrete, standard Indian. We have to define M40 grade. So click OK. Then OK. Add new material. Now this time material type will be rebars, Indian, grade will be HISD 500. Click OK. Then OK. Now again add new material. Now this time we will only have to change the grade to mid grade 250. Press OK. Then OK. Now we have defined the materials. So now it's time to define the section properties. So go to define section properties, frame section, add new property. Now choose rectangular concrete, name it as. Now I'm defining first a beam. So beam, we have 500 into 300. Let me check. Here we're having 500 into 300. So again go to tabs, change the material to M40, 500 into 300, modify / show rebar. As we are defining the beam, so choose M3 design only, beam. Longitudinal bars will be HISD 500, confinement bars will be mid 250. Now change the rear cover or spacing to 25 as per the IS code and click OK. Then OK. Now again copy the same property, add copy property, then define another beam of 550 into 350. Now here we have to only change the dimensions because as we have copied the property, so all the properties will be same. We will only have to change the dimension. Click OK. Now again add the copy of property, then again we will have to change the dimension only. So it will be 400. Now change only dimension to 600 and 400. Click OK. Now go to add property. Now we will define auto select. So choose auto select list. Now we are defining it for beam. So name it as beam. Auto select. Now change the design type to concrete. Now add beams. We have added the beams. So we have now defined the auto select list. So click OK. Now it's time to define the column. So again add property, then concrete, rectangular concrete. Then it's time to define the column. So C 500 into 500. Now material type will be M40. It will be 500 into 500. Let me check once. Yes, 500 into 500. Now go to modify rebar. Now this time we are defining it for column, so it will be column only P M2 M3 design column. Now longitudinal bars will be HYSD 500, confinement bar will be MI mid 250, and here clear cover will be 40. So just add it. Now okay. Now add copy of property. Now we will only have to change the dimensions, because as we have add the copy of property, so it will be 550. It will be 550. Then as you can check it, all the properties have been same. Just okay, then okay. Now again add a copy of property, then C 600 into 600. Now we have to change the dimension. Press OK. Now we have defined all the columns. Now it's time to define the auto select list. So again add property auto select list. Now we are defining it for column, so name it as column auto select. Column auto select. Now auto select design type will be concrete. Now choose all the columns, and now we have defined the auto select list. Press OK, then OK. Now we will define the slab. So for that, go to section properties, slab sections. Here we are defining the add new property, slab. Change the material type to M40, and thickness of the slab is given 150 mm. Press OK. Now we have defined the slab. Now it's time to define the shear wall. So again go to define section property, wall section. Now add new property. Now we will define shear wall. Shear wall. Now change the material type to M40. Thickness will be 300 mm. So press OK. Now we have defined the shear wall. Press OK. Now we have defined all the materials and sections. Now it's time to draw the building. So let's go to draw. Then choose wall floor object. Quick draw wall plan. Now go to property and change it to shear wall. Now change this one story option to the all stories, and now draw the shear wall. Shear wall from story one to from ground floor to the top floor have been drawn. So press escape. Now change all the story option to the single stories, and we will now go to the plan one, story number 1. Apply, then OK. Now we are at story number 1. So we will have to now draw the columns. So we go to draw beam column. Then we go to quick draw columns. Now change the property of the column to column auto select. Now we have changed the property to auto select. Now select the area where we have to draw the columns. We have to choose the quick select, so columns will be drawn only at the intersections of grids in X and Y direction. As shear wall does not have beams and columns, so we will not draw column or beam over there. So I have drawn all the columns, and as I have applied for similar properties, so all the similar properties have the columns. Now press escape. Now go to draw. Again draw beam column object. Now quick draw beam. Now again we will have to change the property to beam auto select. Now we have changed the property. Now it's time to draw the beam. So we will draw it as we have drawn column by simply dragging over cursor. As shear wall does not have any beam and column, so we will select the beams near the shear wall one by one. Means we will draw the beams near the shear wall one by one. Now we have drawn all the columns and beams. So now it's time to draw the slab. So again go to draw. Now draw floor wall object. Quick draw floor wall. Now again change the property to slab as we have defined it as slab. Now select the area where we have to draw the slab. Now choose the slab near shear wall one by one, as shear wall does not have slab. Now we have drawn all the slab, so press escape. Now we have drawn the slab from from story 1 to 8. So now go to story number 9. Apply. You can go to different stories by using this plan option or by using these arrows. Let's check. Up to story 8 we have drawn the slab wall. We have drawn all the slab beam and column. So go to story number 9. As we apply the similar properties, now it's time to define the columns. Here we are having the shortcuts, so we can directly use it. Every time you select the quick column property, so just check the property of the column, that is auto select or not. Now select the columns where we have to draw. Now we have drawn all the columns, so now it's time to draw the beam. So just go to quick draw beam option. Here we are having the property as beam auto select, so now we can draw the beam. Now draw the beam near the shear wall one by one. Now we have drawn all the beams and columns, so now it's time to draw the slab. So just go to quick draw floor wall plan. Now check the property, it is slab. So now we can draw the slab. Now draw the slab near the shear wall one by one. It will take some time. Now we have drawn all the slab, beam and column from story 9 to 12. So now it's time to go to story number 13. Then okay. Now we are at story number 13. And as we can see that all the beams, columns, slab has been drawn to story number 12. So now go to story number 13 and draw column. So again choose the quick draw column option. Here we are having the column auto select. So now it's time to draw column. We have drawn all the columns. Now choose quick draw beam. Here we are having the property as beam auto select. So now let's draw the beams. We have to draw the beams near the shear wall one by one. Now we have drawn all the beams and columns. So now draw the slab. Quick draw floor wall slab. Now we are having the property as slab. Now I can draw the slab. Now draw the slab near the shear wall one by one. It will take some time. Now we have drawn all the slab, beam, column from story 13 to 16. Now go to story number 17. Apply, then OK. Let's check. Story 16 has drawn all the things or not. So here we can see that all the things have been drawn. So again come back to the story number 17 and we will now draw columns. So again go to quick draw column option. Now draw the columns. Now go to quick drop beam auto select, we can directly draw. Draw the beam near the shear wall one by one. Now we have drawn the beams and columns, so now we will draw the slab. We go to quick draw floor wall. We have property slab, so just draw it. Draw the slab near the shear wall one by one. Now press escape. Yes, we have drawn all the beams, columns and slab. Now go to base. Now I am at the base. So now select all the joints. Now go to assign joints, restraints, and change them to fixed support. Apply. Then OK. Now we have completed our geometry part, so now it's time to assign the load. So now for assigning the load, go to the story 1. Now change this property, similar properties to the all stories, as we have to apply a dead load, same dead load to the all the slab from story 1 to 20. So now select the slab one by one. We cannot select the slab by simply dragging, because it will select the columns and beams. So select it one by one. As we have selected all the shells, here we can check it. Here we have selected only shells or frames too. So now we have selected all the slabs. So now it's time to assign the dead load. So go to assign, shell load, uniform, dead load. As we are applying dead load, so it will be dead. We are applying the dead load of 2 kN per meter square. Apply, then OK. We had applied the dead load to all the shells. Now I am applying the dead load to the shear wall, so select the shear walls one by one. I have selected the shear walls, go to assign, shell load, uniform, dead load. I am applying a dead load of 7.5 kN in the downward direction, so just apply, then OK. Here we have applied the dead load to the shear walls too. Now it's time to assign the live load. So for that we have to apply a different live load to the different sets of stories. So now change all the story option to the similar stories. Now we are in the story 1. So select the slab one by one. I am telling another method to select the slab. So here by simply dragging we have selected all the joints, frame members and shell and walls. So now we have to deselect other other members. So for that go to the select, deselect, then object type. Now select the joints, columns, beams and walls. Now deselect, close. As we can see that here we have selected only the shells. So now it's time to assign the dead load, live load. So again go to assign, shell load, uniform, and now we have to change it to live load. It will be live load of 3.5 kN per meter square. It will be in the downward direction, so direction will be gravity. Then apply, then OK. Now we have assigned the live load to all the shells. Now from story 1 to 8, now go to story number 9. Now again select the slab, deselect object type, columns, screens and walls. Deselect, close. We have selected all the shells. Now it's time to assign. So go to assign, shell load, uniform, live load of 4 kN per meter square. Then apply, then OK. Now we have assigned the live load from story 9 to 12. So again go to the story 13. Now again select the shells. Now we have selected all the shells. Now assign, shell load, uniform. This time it will be 4.5 kN in the gravity direction. Okay. Now we have assigned the live load from story 13 to 16. So go to story number 17. Now select the shells. Now I have selected all the shells. So just assign the load, live load. It will be 5 kN in the gravity direction. So here I have assigned all the dead and live load. Now it's time to assign the dead auto cladding load to the outer beam members. So just go to the story 1. As we can see that for different stories, outer wall will be different. So choose this option to the similar stories. Now again select the story outer beams. We can simply select it by one, but I am selecting it by simply dragging. Then again go to deselect, object type. Now this time we need beam. So just select joints and columns, deselect. Now as we can see that here only the frames have been selected, so just close it. Now all the outer frames have been selected. So go to assign, frame load, distributed. We have to apply the frame load of 0.2 kN per meter, so just apply, then OK. Here we have applied the cladding load. So we have applied the cladding load from story 1 to 8. So go to story number 9. Now again select the outer frames. By selecting this, we are not only selecting the outer frames, but we are also selecting the joints and column. So for that we have to go to deselect, object type. We have to deselect joints and columns, deselect. So now we have selected only the beams, outer beams. So go to assign, frame load, distributed, 0.2 kN, apply, then OK. Now we have assigned the cladding load from story 9 to 12. So go to story number 13. Now we are at story 13. Just before check it. Now select the outer frames. We can select it one by one, but it will take time, so I'm just selecting it by dragging, and after that I'm deselecting the joints and columns. Close. Now we have selected all the outer frames, so now assign frame load distributed 0.2 kN, apply, then OK. Now we have assigned the dead load from story 13 to 16, so now go to story number 17. So we are at story number 17. Now select all the outer members. Now deselect joints and columns. Close. Now we have selected all the outer frames. So now go to assign frame load distributed 0.2 kN. Apply, then OK. Now go to story number 20. As there will be no cladding load, so we will have to remove the cladding load. So again change the, here we are not having the option of poly story or single story, so again go to display, undeformed shape. So here option has came, so now just select it to one story. Now we are at story 20, so select the outer members, deselect joints and columns. Now we have selected all the outer frames. Now go to assign frame load distributed. Now delete the existing load, apply, then OK. So now we have applied all the dead and live load to the building. So now go to draw for drawing the auto cladding. Select auto cladding option, use floors, then OK. Now here we can see in 3D view the cladding has been completed. To see the cladding from different direction, we can use rotate 3D view. Now cladding has been completed. Now as we have assigned all the dead load and live load to the building, now it's time to define the wind load. So go to define, load pattern. Now name it as wind, dead load wind. Now choose the IS 875 1987. Now click add new load. Now select the wind load and modify electric load. Now for wind speed, that is the basic wind speed, we have to go to the IS code. So IS code, we have to go to appendix A. So here we are at appendix A, basic wind speed. We are designing it for the Bangalore. So for Bangalore it is 33. So set it as 33. For terrain category, we have to go to the IS code, then go to the table number 1. No, not table number 1. here we are having the terrain category. So Bangalore comes under the category 3. This category 3. So just change it to category 3. Now structure class. But again go to the IS code. And as our building height is more than 50 meter, so class will be C. So then go to ETABS and change the class to C. For risk coefficient, again we have to go to the IS code and table number 1. So here we are having the risk coefficient factor. So we are designing it for the 50 years, so it will be 1. So keep it as 1. Now for topography factor K3, we have to again go to the IS code. Upwind slope for the Bangalore is less than 30 degrees, so topography factor will be 1. So again go to topography factor, then it will be 1, then press OK, then OK. Now we have defined the wind load. So now it's time to assign the wind load. So for that, go to the elevation A, apply, then OK. Now go to the change this option to the all stories. Now select the shells. Don't select any frame. So here we can see that we have selected all the shells. So now go to assign shell load wind pressure coefficient. So for wind pressure coefficient we will again have to go to the IS code. So our height by width ratio is 2.4, so it will come under this category, and our length by width ratio is 1.2. So we have to see this subcategory, and under this category wind is falling perpendicular to the building, so we are considering theta as 0. So our wind coefficient will be plus 0.8 for A, minus 0.25 for B, minus 0.8 for C, and minus 0.8 for D. So as we are assigning the wind load to the A, so if we have to apply plus 0.8 wind coefficient, just plus 0.8. So it is in windward direction, so just keep it as windward, then apply, then OK. Now again go to elevation. Now go to elevation F, apply, then OK. Now again select the shells one by one. Don't select the frames. So we have selected all the shells. Now it's time to assign cell load wind pressure coefficient. Now again go to the IS code. Now we are applying the wind load for the B. So for B it is minus 0.25. So it will be minus 0.25 in the leeward direction, that is from side. So just apply, then OK. Now go to elevation 1, then apply, then OK. Now select the shells. Don't select the frames. Now go to assign shell load wind pressure coefficient. Now this time it will be minus 0.8. Apply. Now go to the elevation 7. Now different numbers of shells are outer shells for the different sets of stories. So now select the story, select the shells in the elevation 7. Now go to assign the wind load, so wind to pressure coefficient, apply. Then go to elevation 6. Now again select the shells. Now go to assign shell load, wind pressure coefficient, apply, then OK. Now go to elevation 5. Now again select the shells. Assign shell load, wind pressure coefficient, apply, then OK. Now go to elevation 4, apply, then OK. Now select the shells. Assign shell load, wind pressure coefficient, apply, then OK. As we will define all the loads and assign all the loads, now it's time to analyze. So just go to analyze, run analysis. Before that we have to save our project, so just save it as ETABS. Save it. Now it will take some time. So as the height of the building is too much and we are having the different stories and lots of numbers, so it will take time to analyze. Here we can see the status of analysis. As the analysis is complete, so here we can see the displacement values. Now it's time to design, so just go to design, concrete frame design, view, revise, preferences, and if it is not IS 456 2000, so just change it to IS 456 2000, then press OK. Now again go to design, concrete frame design, start design check. Now it will take some time. Wait for a few minutes. As we have applied the auto selection, so software is asking us to change the dimensions of the various frames which have been filled. So here 1692 frames have been filled. So software is asking us to change. So just press yes. Now software will again analyze and design, and now it will increase the dimensions of the filled member as we have defined the different dimensions of beams and columns. So it will just increase one level. It will increase the dimension of the members, and again analyze it and again design it. Now it is again designing. Complete design check is in progress. Take some time. Now here in 3D view you can see the longitudinal reinforcement values. Now for the various another result we will have to go to display, then force stress diagram, then frame tier, then click on shear 2 now we can see the shear diagram of different members in the 3D view. And for the moment choose M33, apply, then here we can see the various moment diagrams, and press OK. To see the basic analysis, go to 3D view and right click. So here we can see the basic analysis. Now close it. Now for report we have to go to the reports. Now click on project report. Time. Before creating the report, first we should check the all members are passed or not. So go to concrete frame, verify all members are passed. So we can see that all members have passed the design check. So press OK. Now we can see the project. Then click on project report. Here we will have all the details of our project. From here we can create the report of our project, and in report we are having all the detailings. We have all the results of our analysis. We can also create a summary report. Thank you. Now all the outer walls of the building. So now it's time to analyze.